In this lesson, we will learn how to graph lines. Now, if you're like most people, you probably spent some of your school years graphing lines such as these. And if you're like many people, you aren't entirely sure what the relationship is between these equations and these lines. So before we go any further, I think it's important to have a solid understanding of what it means to graph a line. Now, to set this up, I first want to talk about why we even need to graph lines in the first place. Now, as you have already seen, we can solve equations like this one. Here we subtract 5 and then divide by 2 to see that x equals 3. So this equation has exactly one solution. Here's another equation that can be easily solved, and once again we see that it has exactly one solution. We also know how to solve quadratic equations by factoring. When we solve these equations, we often get exactly two unique solutions. Notice that in each of these examples, the number of solutions is finite. Compare these equations with this equation. The first thing we notice here is that we have two variables. So we are looking for a pair of values, x and y, that satisfy the equation. Well, x equals 2 and y equals 2 is one possible solution. X equals 1 and y equals 3 is another solution. And so is x equals 0 and y equals 4. We can also have x equals 3.5 and y equals 0.5, as well as x equals 5 and y equals -1. In fact, as you probably already know, the solutions can go on without end. So how do we handle this? How do we show every possible solution to this equation? Well, that's where the coordinate plane comes in. We can take this solution and represent it with the point where the coordinates of that point are x equals 2 and y equals 2, just as in the solution. Similarly, we can take this solution and represent it with the point with coordinates x equals 1 and y equals 3. We can do the same with this solution and the same with these two solutions. Of course, we could add infinitely many solutions to this equation, and if we added all of them to our coordinate plane, we would get a line that extends forever in both directions. We say that this line is the graph of the equation x plus y equals 4. Now, the most important takeaway here is that this line is really comprised of infinitely many points, and each point is a solution to the equation x plus y equals 4. Now, when we say that a point is a solution to the equation, we mean that the coordinates of that point satisfy the equation. So the x-coordinate of this particular point is 1, and the y-coordinate is 3. And when we take the equation and replace x with 1 and y with 3, these coordinates add to 4, which means they satisfy the given equation. So from what we know now, how do we determine whether the point 31, -28 lies on our line? Well, for that point to lie on the line, its coordinates must satisfy the equation of the line. When we plug 31 in for x and -28 for y, does this equal 4? The answer is no. So the point 31, -28 does not lie on the line. Okay, what about the point 15, -11? To find out, we'll take the equation of the line and plug 15 in for x and -11 in for y and see if this equals 4. Since it does equal 4, we can see that the coordinates of this point satisfy the equation, which means it does lie on the line. Okay, now let's get some practice graphing lines. We'll begin by graphing the line that corresponds to the equation y equals 2x minus 3. To graph this line, we need to find some solutions to the equation. Since the equation already has y isolated on one side, we can take our equation here and plug in values for x to find corresponding values for y. So, for example, let's say that x equals 0. If x equals 0, we can replace x with 0 and simplify to see that when x equals 0, y equals -3. So one solution to the equation is x equals 0 and y equals -3. Let's take this solution and place it in a table. From here, we'll choose a different value for x. How about x equals 2? If x equals 2, we will replace x with 2 and simplify to see that when x equals 2, y equals 1. So we have another solution, x equals 2 and y equals 1, which we can add to our table. Now when it comes to graphing lines, we really need only two solutions. However, if one of those solutions is incorrect, then the line will be in the wrong place. So it's not a bad idea to find a third solution so that if all 3 points line up, then you know that the line is probably in the right place. So let's choose one more value for x. How about x equals 4? If x equals 4, we'll replace x with 4 and simplify to see that when x equals 4, then y equals 5. So we have our third solution, x equals 4, y equals 5, which we can add to our table. Now that we have three solutions to the equation, we are ready to graph our line on the xy coordinate plane. The first solution can be written as a point with coordinates 0, -3, and this point is right here. The next solution can be placed here, and the last solution can be placed here. When we connect these points, we get a line, and this line represents all of the solutions to the equation y equals 2x minus 3. Now in this last example, the equation was already written so that the variable y was isolated. This allowed us to quickly find solutions by plugging in various values for x and then finding the corresponding y values. However, sometimes our equations will be written something like this, where one variable is not isolated. So one option here is to take our equation and isolate one variable so that we can quickly find some solutions. Another option is to plug in some nice values for one variable so that it will be relatively easy to find the value of the other variable. So for example, if we take this equation and let x equal 0, we can see that 2y must equal 6, which means y equals 3. So we already have one solution. Now notice that if we let y equal 0, then 3x must equal 6, which means x equals 2. Since we now have two solutions, we can graph our equation on the xy coordinate plane. The first solution can be written as a point with coordinates 0, 3, and this point is right here. The next solution can be placed here, and we now have enough points to sketch our line. So this is the line corresponding to the equation 3x plus 2y equals 6. Okay, let's summarize. In this lesson, we learned that when it comes to graphing lines in the coordinate plane, a line is a set of points such that the coordinates of each point satisfy the given equation. If the coordinates of a point satisfy the equation, then that point will lie on the line. And finally, if the coordinates of a point do not satisfy the equation, then that point does not lie on the line.